we make sure that the GMES outputs and INSPIRE activities are more closely interdigitated. But just to give you a sense of the variety of what we will be receiving, we will get altimetry, which will tell us about sea level rise. We will have enormous ability to talk about changes in land use. We'll be mapping the Arctic through cryosat. We'll be looking at upper tropospheric and upper atmospheric conditions, which will tell us about air quality and therefore human health at ground level. We'll have a lot more information about biodiversity. And of course, we will have a lot of high precision information regarding the positioning of infrastructure. So more and more, as we move towards programs that are orientated towards climate change, adaptation, and mitigation, these will be the source of a lot of information that maybe you in public administration or in the scientific community will need to have access to and be assured of its quality and also its accuracy in terms of georeferencing. So this range of sentinels then, together with our own work in the agency, where we are, in a sense, empowered to bring the in-situ coordination together with Earth observation. Now, what does that mean? Well, of course, that means not only georeferencing, but also checking and coordinating where we have in-situ measurements to correct and to adjust some of the Earth observation data. So the work of the agency, I think, is now really finding the need for the dialogue, I hope, that will go on during the course of this week. You can see some of the structures around the architecture. There's the services with value multipliers. These are the downstream service providers. But for the next 3 to 4 years, there is a public good creation. In other words, between the commission services, ourselves, member states, there's a need, in a sense, to secure what is in the public good, which will then be made freely available, will be paid for, and that which then creates value-added products downline. And that sort of division and the data policy around that, of course, is what is being discussed in some detail. Just to give a kind of crossover then between GMES and INSPIRE, what I've tried to do here between the Annex 1, 2, and 3 is to identify where we see direct links between the various services. And you can see the ones that I've highlighted, the land services in red, the ones in blue, the marine, and the atmospheric services in green. And you can see there's quite a number, even in the Annex 1, where there's going to have to be sort of coordination between what GMES will be producing. And now, of course, this will be on a very regular basis. In some cases, we will get updates every, well, in one case, every 6 hours, but mostly it'll be every 24 hours, or if not, every week. So we'll have some geostationary, we'll have some low orbit, but essentially most of these will be updated very frequently. So you can see there's a whole range of services and GMES requirements within the INSPIRE annexes, and similarly here going on into the Annex 3 even more, because as you know, these are very much towards where we're moving in some of our service elements. So a lot to be done, a lot to be aware of, I think, insofar as I think it would be fair to say there is little dialogue at the moment between the GMES community, the space community certainly, and I think yourselves. So I guess what I'm trying to say is have the dialogue early, and let's have a discussion already to make sure that we don't get ourselves into 2 parallel tracks and actually they're not talking to each other. So if I can leave that one with you. There's a huge motivation, of course, to do this well, not only because we want to do things in a comprehensive way within Europe, but also because we want to link it to our global partner programs. And GEO and GEOS, I think, really see the GMES contribution as being not only Europe's contribution to the global setting, but also to help a lot of countries who perhaps aren't going to invest even in the in-situ coordination to use what we do as proxies for their own work. And so we can already see that much of the development that we've done here, here's an example where we've worked with the farming community, taking our Korean land cover down onto handheld PDAs and linking that then, of course, to much better low input agriculture practices, low tillage, low fertilizer application, so on, but also water mapping in high areas of semi-aridity. But also the idea that we can do compliance testing and actually bring that all the way through, in our case, to the subsidies that come from the CAP. Now, this whole sequence of linking information together, high precision down to the level of the field, which is then, of course, checked by other procedures with Eurostat and DG Agriculture through programs such as Lucas, are incredibly important when we think about the climate change program, where we will want to have a discussion with many of our colleagues around the world in a non-obtrusive way to actually say we are able to provide monitoring, reporting and verification schemes. And this is a real political hot potato, because this is the one where many countries feel that they do not want others, so to speak, looking over their shoulders. They want their own systems to effectively reinforce what they have at home. So in one way or another, we need to not only be technically neutral, we need to be politically neutral, but at the end of the day, we need verifying systems that can be transported and exported very easily. And this is one example which we know will work. Another one which is a little bit more sophisticated, but we think is very fit for purpose, and of course right now in the Gulf, I bet they wish they'd had it. This is the nervous system of the North, which the Norwegians have been preparing, which is an in-situ satellite-connected program, really telling us down to the precision of 2 millimeters where there is crustal movement, but also linking all the way up to surface layer spills. So here you see a coordination of not only a demand for environmental protection, but also at the end of the day, because of the precision that we're getting from the satellite altimetry and the GPS coordinates, we can actually see crustal movement to the point where it makes a difference as to where the drilling rigs actually place the oil heads. So in a way, this of course is what should be in place everywhere, but the precision that we now have from our GPS work shows that we can detect meaningful distances which are important, as I say, even for the deep sea oil. Now this is important, of course, for the Arctic, given how sensitive and fragile an environment it is, and therefore, in one sense, further exploration into deep ocean, particularly in the north, will be provisioned by this kind of sensor web to be ensured that that high spatial precision is really available, not only to the industry, but also to the administrations that have to monitor, protect, and look after the environment. And finally, on land, we see that there's a proliferation of the possibility of putting very cheap sensors out into the field. They will have to be geolocated, but what they enable us to do is to identify very close to home where there are changes in, for example, volatile organics, a whole variety of gases. These sensors we're trying to develop at a very cheap level. You can buy some at the moment in the US at less than $5. And the idea is to put them into areas of high risk. For example, in earthquake-prone areas where we know that the emission of gases just before an earthquake is a very strong signal. So there are all sorts of ways in which we anticipate being able to use this. So the civil protection services will also, I think, value this kind of input, high precision spatial data infrastructure, and this is an extension of it. And in the end, we also, of course, worry about biodiversity. And 2 weeks ago, we launched the new Biodiversity Information System for Europe. And this is a prototypic example of where we think, ultimately, the INSPIRE discussion feeds into. We have a very large meeting in Nagoya towards the end of this year, in which we will debate and discuss amongst the nations how we are going to set a target to avoid the loss of biodiversity. And whilst in Europe we may be not quite so sensitive about some of our borders, there are many places in the world where very, very finely tuned borders protect or do not protect a lot of wildlife. And therefore these property rights are not only highly contentious, but need to be extremely carefully mapped. So we see that BIS, the Biodiversity Information System for Europe, really does provide a prototype when you know what happens behind it, because it's not only our nature protected areas, the Natura 2000, but it's many, many other highly specified areas where we know there are breeding birds, endangered species, so we have spot locations for them. We know that this is the kind of information that we need to provide into the decision making at that level. And then finally, I would say that one to be discussed is last week we had within Europe made into legislation by 2012 that it will be illegal to import timber and timber products from any timber that is grown in a non-sustainable way or is harvested illegally. And that includes all products. That's furniture, not paper, but certainly all downstream products. This comes into effect in 2012, That means that any country that wants to import timber products into Europe has to have a certification procedure in place.